Welcome, everybody. It's nice to see you all on time. We'll be beginning in just a few minutes, waiting for more people to come. Hang tight.
Hello, hello, testing, testing. Joining in now. Raise your hands if you can hear me, please. Thank you very much. Okay, let's get set up here. Okay. Get the screen going. All right. And we are rolling. All right. Welcome, everyone. Thanks for joining us again. There are, I guess, just about enough of you guys to get started. Maybe I'll wait one more minute to see if anyone else fills in. Other than that, actually, you know what? For these first few minutes until everyone comes in, let me just, why don't we go ahead and just follow up a little bit from where we left off last time. I was hoping to get more stuff achieved, but actually, you know what? Here's what I'm going to do. Like I said, I do apologize. I didn't manage to go through everyone's homework submissions in the past few days, and I feel really bad because some of you guys made some amazing stuff, full package, HTML, CSS sheet, looked like very clean code. Sometimes you guys really like zipped it up in a folder and everything, you know, well presented, and I just did not find the right times to look through it. But I did get to see some of you guys' stuff. So why don't I just copy paste in here one of the most recent ones that I saw, and I'll just go through that, and we'll just play around with that a little bit to finish off what I was going to go through last time. Just spend a few minutes on this, not too long. So here's my code editor. I'm gonna copy this folder, project. Okay, we have a new folder here. Copy, open up the main HTML file. I'm gonna paste in what I got from this awesome course joiner here. And here is his code submission. So he went a little bit of a different route with this styling, because I recommended that we do things the way ideally they should be done, which is that HTML is in one file, the HTML file, and any styling belongs separately in a different file, in a CSS file, and then you pull it in by using the link tag in the header of the page. But over here, he went ahead and just made a style tag in the HTML, which kind of allows you to write CSS straight into the page. I didn't even tell you guys about this. And turns out there's even a third way how you can put CSS in your page, and I'm really not going to tell you guys about that one, because these are progressively less and less advisable ways how to do it. The best way is to have your HTML file and your CSS file separately. This way, putting the CSS in a style tag inside of your HTML is doable, but for many different reasons, not advisable. But this is what he did. So we're just going to see what it looks like. And this is all the actual HTML code. He took the approach of doing a table with TRs and TDs. And to be fair, I do not know exactly how much individual creativity and HTML knowledge was applied here, and how much possible inspecting and copying from the Top Baby Deals website went on here. I'm going to assume, because I want to assume, that this guy was so awesome that he just came up with all of this just from memory, just from Googling, just from MDN documents. So let's see what it looks like. Let's open this page up in the browser. And here's my browser, here we go. So yeah, I personally was pretty impressed by how close enough, not very close, but close enough this appeared and had the look and feel similar to the original Top Baby Deals website that we looked at. Here we go. You can compare this to this. Pretty similar. Not exactly the same, but it was a very good effort at making them as comparable and as similar in visual style as possible. We didn't go as far as doing the thumbs up and thumbs down. I told you guys that's fine. You can leave that out for now. Just the important parts, the number, the image, the link, the text. Very, very well done. So let's just quickly for a few minutes inspect some of this CSS and just play around with it and see what it's about. So let's start with over here. This aside just a little bit. As you can see, if you change the size of your browser or of your screen, your web page is going to look different depending on different people's screen. Before, when I didn't open up the developer tools, this was a much wider browser and you had a lot more space, so the text kind of presented itself differently. I also zoomed into this page so that you guys can see it clearly. Without zooming, it's even more spacious. However, on smaller screens and on mobile devices and in different situations, your website might appear in different ways. And that is something we need to learn about in CSS styling, which is called responsive web design, which means that you test your website in different sizes and different devices and different situations, and you make sure that in all of them, there is some sort of arrangement and appearance that works. And it doesn't ever come to a point where like, oh, that guy and that kind of size, reasonable device that he was using was browsing your website and it looked pretty crunched up and things were messed up and they couldn't read it and couldn't work with it. There are some people that try some unreasonable things. You know, I don't think there's anyone that's going to browse your site with something like this. Okay, so here, as you can see, I really smashed the website and no one has a device this narrow and no one's going to zoom in that much. And if they do, they deserve what's coming. This is how the site is going to look like if you mess around with things like that. But for reasonable sizes and reasonable devices, your web page, ideally, if you design it well and you plan things out correctly and you use good CSS tricks as they should be used, should be able to present itself well on many different screen sizes, devices, etc. As you guys can look up, Google about responsive web design, responsive CSS. Okay, so let's quickly just look at one or two things over here and move along with the main subject of this course, of this class today. See, we're already, most people are here. Let's look at the header. See, the header had some styling over here to have a certain font. What if I take away that font? It's a nice font, Gil Sans, pretty cool. If I uncheck that font, we see that the header font falls back to the usual default font like Times New Roman. And yeah, that looks how that looks with serifs and all that. But this is like a more unique style kind of font. So depending on the design and look and feel of your website, this might be the right font to go with. Opening up the header, I'm going to go into this nav element. Very cool. So you're using the nav element because nav is for navigation. Usually in headers of websites, you have a lot of different links, browsing to different parts of the website. That is an appropriate place to sometimes use the nav tag. Although in this situation, there isn't really that much navigation going on. So maybe it's available and ready for navigation links in case you want to add some in. But for now, it isn't really navigation per se, although it does have login and sign up. But let's see. What did you style with the nav bar? You made the background color. So if I uncheck that, just remains white. We can play around with this color. If you actually click on this in Google Chrome, you can get a nice little pop-up dialog where you can mess around and test different colors. Hey, what would it look like if I made it pink, you know, bright pink, red, yellow, orange, different things you can play around with over here. And interestingly, if you want to get used to how you describe colors in CSS with that kind of coding, you know, hash 00FF stuff like that, you can actually, if you play around with this little color dialog over here, it'll give you a lot of interesting hints and you can see how it makes sense what the numbers are in RGBA, or if you click on this, it's going to switch to HSLA, or if you click, it's going to switch to hex. That's that standard CSS kind of coloring scheme that many people often use. And you see, as you move around the colors, you see the letters change. Now I'm in 76A5B6, but now I'm in 00B8FA. And as you play around, you'll start making sense. Like, here, I'll give you guys one little hint, and you'll figure out the rest from there. The first 2 digits of this code is the red part of the color. The second 2 digits is the blue part of the color, and the last 2 digits are the green. No, I'm sorry, the second one is the green, the last one is the blue. RGB, red, green, blue. And as such, oh, and also one more thing, the numbers count all the way up to 16. What does that mean? Usually we count in base 10, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and then from 9 it goes up one more place and it goes to 10. But these numbers actually count up to 16, which goes like this: 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. So because there aren't more number numerals, they're borrowing from ABC numerals to make as if that's a number. And so you're counting all the way up till 16. Why? Because computer bits and bytes work with number 16. We'll learn about that maybe another time. And so after 16, you move on to number 10, so to speak, because you're moving on to the next place. So then the first place is 0, and the next place is a 1, and then the next place can go to 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F, etc., etc. So 0 is the lowest number, F is the highest number, and if this is red, the first part is red, this middle part is green, and the last part is blue, you can get a complete color if you follow that number. If I do FF 00 00, that means I put one complete, the highest number of red in the first 2 digits, and I took away all the other color in the rest of the digits. So in that case, we get completely red. If I move that over to the greens place, and I remove the last digits over here, now we have 00, FF 00. So the first 2 digits of red are 0, the second 2 digits are green, etc., etc. And then the last one will show you blue. And then you can start making combinations. What if I mix red and green? What do we get then? Well, FF00 gives you yellow. Combination of red and green apparently amounts to yellow in the way the computer works with colors. And if I make everything FF, that's white. If everything is 000000, that's black. And if I do some number in between, like equal parts red, equal parts green, equal parts blue, then that's going to be a very dark shade of gray. If I put it somewhere in the middle of the spectrum, 888888, that's going to be a middle kind of gray, etc., etc. You guys can figure out already from here the different ways how you encode colors and how you can express any different kind of color at all using this code scheme. So that was a little tangent about the idea of colors. Let's set it back to the original color that it was, which was code 3EA4C9. Great, nice shade of blue over there. He also gave it some padding. Padding is something that's good to know about and very useful. Padding basically means that any element that you have, if you think of an element as being in a certain kind of a box, and inside of that box, that's where the content that goes into your HTML tag lives. So if you want to give it a bit of a space around itself, it has 2 different kinds of space you can give it around itself. One is it's inside of its own space, and the other one is outside of its space. So think about it like if you're sitting in a chair and then you move in your immediate space, you just kind of squish yourself in so that you have a bit more space around you. That's padding. You're making some padding space immediately in your own space. That's called padding. That's inside of your box. You're making space, pushing the content inward, making space inside of your box for stuff. Outside of your space, that's called margin. If you want to give yourself some space around you. So let's say you push the stuff that's away from your chair this way, and you push the stuff that's outside of your chair that way, and you give yourself space around your chair. That's called margin. You're giving yourself space around yourself. So here he gave 5 pixels of padding around this header. If we took away that padding, what effect does that have? It's very, very small, but you can see there's a difference over there. It gives itself a bit more space to breathe, sort of thing. And if you mouse over it, you can actually see Chrome will highlight for you a little green border around that element that shows you this amount of pixels is giving padding. Let's exaggerate it a little bit. I'm going to mark up this number 5 much higher. I'm going to mouse over it. Now you can see I have 35 pixels of padding pushing itself into its own space. Let's see what would be if we did margin. I'm going to add another style over here. What I did was I basically clicked with the mouse in here in the CSS in the browser, and Chrome automatically gave me, oh, sure, you want to type some more CSS right here, right now? You want to hack it into the page as is? Go ahead, add some more stuff right into the page. This, of course, is going to disappear as soon as you refresh the page, because this is just on the spot right now in the browser, edits and hacking around that you're doing, but later it's going to disappear. But I'm just testing things around, you know, so I'm adding a margin of 10 pixels. This one is going to be a lot more apparent. When I mouse over it, it's showing me space outside of this element. And if I increase that space, as you can see, it's pushing the element out of the outside space, making it narrow and narrower for itself, because outside of it, as you can hear, we can actually see the combination of both. Let's see if we give it 20 pixels of margin and 20 pixels of padding. So now margin, as you can see, is highlighting outside of the element, and padding is highlighting inside of the element. So there you go, the difference between margin and padding. Anyway, enough about that. Let's look at one or two other little things and move right along to the main subject of today. We made an image, we gave it a height. You can change how tall and short something should be, how wide and narrow something should be with the height property. Here he gave padding left. There are some things in CSS which have subsections of it and subparts of it. You can either talk about the padding of the whole element, that's around all of its 4 sides, how much padding should it have, or you can talk specifically about only one side. I only want to add some padding on one side. I don't want to add padding on the other sides. Or for example, think about adding a border, right? Usually a border, you think, oh, a border goes around, all around whatever it is you're talking about. It's bordering all around it. But you can sometimes say, no, I just want 2 lines on the bottom and on the left, and that's it. I don't want to have the other borders. So you can refer specifically to each one of these areas. I only want to make border on the side. I only want to make border on the bottom, on the top. So there are subsections of things in CSS that you can do. Let's just go a little bit to each row in the table over here. I'm going here to the TR. Let's see, what does the TR have? Not really much styling over here. We did border collapse. Border collapse helps make combined borders in a table. If you have a chart, think about each little box in the chart has its own border around it, and then the next box has its own border around it, and there's a bit of space between those boxes, and it looks kind of weird. Why does each box in the chart have its own unique, separate border around it? But border collapse is a style that makes everything combined together. If you have a left wall and I have a right wall, then we're going to combine it together. We're not going to separate them as 2 separate boxes. We're just going to mix my left with your right, and that makes one line that combines between us. The same for top and down, etc., etc. So this is what border collapse does. Okay, let's step into the TDs of this table. All right, so we have a TD with border bottom. That makes a line between each of the rows. Pretty cool solution. So for every cell in this table, you're telling him, give him one line, one border on the bottom. And the total result of that is that we can see there's a, there's my little highlighter here. We can see there's a line happening here on the bottom. If we, for example, added more borders, let's say if I took out the word bottom and I said, have a border. I'm not telling you have a border on the bottom, just have a border. Then you'll see now we have the entire grid showing. Every single line around the whole row, around every single cell is showing. But he didn't want that. He only wanted there should be a line on the bottom, only to separate between one row and the next row and the next row. And that's achieved by border bottom. Very cool. Padding top, padding bottom. Okay. Let's step inside of the TD. Inside of the TD, we have a span. Very cool for finding a span. I don't remember discussing the span, so that means you must have Googled it and you must have found what it's about. A span is kind of like a generic containing element for different stuff that you have inside of text. So it's like if you have a bunch of text, but part of the text needs to be bold, or part of the text needs to be emphasized. So really, there's just a whole bunch of text, but you want to single out a specific part, a specific span of the text to do something special with it, then you use the span element, because otherwise there's no particular reason why this text is any different than any other text around. But if there is something to single it out for, you use the span element for that. And in this case, you only have a span. There isn't any other text going around. And for the span, You just needed something to surround the number 1 number and give it some important styling, number circle. You gave it a class. Very good. Span with a class attribute of number circle. And here we have a whole bunch of CSS stylings, which I'm guessing does the magic of this circular border around it. You found how to do the border radius. Very cool. Usually, a border radius just gives you a bit of rounded corners, is what it was initially meant for. If you usually have a border around the element, it gives you a line on top, a line on the side, a line on the bottom. That's what a border is about. But then they said, hey, wouldn't it be cool to make in CSS an effect that instead of everything being rigid, sharp edges, you could make them kind of cool and rounded around the corners. So they gave you border radius, which is supposed to look something like this. Now you see the numbers over there. They have a box border around them. I'm increasing the border radius a little bit. And you can see now the corners are a little bit more nicer, a little bit more presentable, a little bit more easy to look at. Because it's like, it's nice, it's cool. It has like a rounded corner. That's what it was meant for. But then, obviously, as developers, we always like to hack things around. And so if you make the border radius really, really large, the end result ends up being that it's a circle. You came in with the corners being so rounded that now the whole thing is a circle. That's one trick how to make a circle in CSS. You give it a specific width, height, padding, background, and you obviously have to give it the color and the type of border you want it to have. You know, here he did solid. We can do dashed. So now we have a dashed border. You know, it's like little dots going around rather than it being solid, dashed. There's a bunch of other different options you can do. And the color, which he did in the RGB format, very cool. That's like another level up over here. I'm used to doing the hex format, you know, the hash symbol with those digits, but he did it with the numbers. Very cool. Okay, very nice. What if we did light green borders? Isn't that cool? Okay, let's move on for now, even though there's more details to be looked into. Let's start going ahead with what we were going to focus on in this particular class. So ideally, at some point, which is also the reason of this new background behind me, we're going to start learning a bit about actual programming here. Now, what do we mean by actual programming? This whole course has been about programming. Yeah, but in a way, HTML and CSS are a little bit different than your usual programming language. They're what's called a declarative language, which means that they're just here to state their case and be gone, right? An HTML document basically tells the browser, just be this, done. That's it. As long as you can be this, we're good. This is the structure of my page, okay? I'll tell you some facts here. Here's the heading, here's the content, here's the footer, we're done here. That's it. That's the fact. So that kind of programming is called declarative programming, where you're just basically declaring some things. Here's what it is, and that's it. But real programming, so to speak, is a lot more juicy than that. And as soon as you guys figure out the power of the real programming going on here, that's when you're really going to start discovering all the fun, and you're probably going to be pouring JavaScript all over your website like this guy over here. JavaScript is what adds the life, the breathing, the heartbeat, the things are happening in your website, in your web page. Until now, your web page was basically, it is what it is, and it's just a page that has elements and stuff in it, and it has also appearance, you know, it has CSS, it has styling, but it basically is what it is, and it's sitting there, and it's dead in a way. It's like, this is what I am, and that's it. JavaScript comes along and says, hey, we can do some active, interesting things over here. We can make things move around. We can make things animate. We can make interesting things happen however you want to do, whatever you want to do. We can change stuff in the page. To begin with, your HTML page may have had a table and some rows and some, some elements in there. With JavaScript, with programming, you can decide, hey, it's time to, because he pushed this button, it's time to fill in a whole new different section on the side. I'm going to move away the table, make it animate to push away on that side, and now I'm going to bring in a whole new different part with a div, with H1s and paragraphs and links, with things moving around and jumping around, right? So this is different than just writing an HTML page where it is what it is, and you're telling the browser exactly what to show, and the browser shows that. Now we're telling the browser, and this isn't just a dead final fact and that's it. There's more to it. There's more life to it. There's more things that are going to be happening during the lifetime of the person browsing the page. And that's what we're going to be doing with real programming now. So I'm going to open up the browser over here, and I'm going to spend some time in Developer Tools. This is the first place where we can start playing around with JavaScript programming. This is a little bit kind of like when we first started making web pages with CodePen. So CodePen was like a quick place where you can test things around a bit and start writing a bit of HTML and seeing what the results looks like. But the real deal was when you wrote HTML in a file, saved it on your computer, and opened it in your browser. That was like the real deal. So the same thing over here. I'm going to be using what's called a console. Usually when you guys were opening up the inspect, the developer tools, you were probably in the elements tab over here to inspect the elements of the browser and see the HTML and see the CSS. Now I'm going to be moving over to the console. The console is basically a little area where the Chrome browser tells me, and by the way, if you're using Firefox, it has all of this as well. The Chrome browser tells me, here, do you want to mess around a little bit with your JavaScript? You can type over here some commands, and you can make some things happen as if you type them into the web page. Usually, eventually, you're going to be writing up all of your JavaScript in the web page in a separate JavaScript file. But over here, you can test around with things, play around with things a little bit, which is sometimes very, very useful to do. So what am I saying, JavaScript and programming and all that? Let's just remember real quick, recap some things we learned about in the first class. I'm just going to go over it real quickly. What is programming? Programming is you having control on your computer, over your computer, you commanding it, you driving it, do this for me, do that for me, and it follows your command. It's like your little pet robot. You can command it to do this, that, the other, and it will follow all of your instructions exactly. So we're going to make that happen now in web pages and websites. After you built a website, you can make all sorts of things change and move around, and things happen. This is also general programming concepts also, by the way. As we're going to be learning now about variables and functions and loops and if statements and stuff like that, we're going to be learning it for our purposes in the browser for a website. But really, these same concepts exist on so many different levels in many different languages. If eventually down the line you might be working on server-side code with PHP, with Java, if later on you're going to be making an app on iOS or on Android, you're going to be writing code with Android Studio or with iOS, Objective-C++ or Swift or any different stuff like that. These same concepts are going to apply. It's just that every different programming language has its own flavor, its own syntax of how it likes to express things. So if you remember, we learned that programming languages is kind of the language of the computer. In order to talk to the computer and tell it what to do, computer doesn't speak English yet, so we have to learn his language and talk to him in that language. So far, we've learned two different kind of languages. We learned HTML5 and we learned CSS. And those languages helped us write certain kind of code which instructs a browser how to show a page. Now we're going to start learning about another programming language called JavaScript, or for short, people abbreviate it to JS. In fact, when you write a JavaScript file with JavaScript programming code, you're going to be saving it to a file with the extension .js. So this is another type of file we're going to be learning about. Until now, we did HTML files, we did CSS files, and now we're going to start doing JS files. So here's the thing. JavaScript is very cool in the web pages and on a website because it helps you mess around and play with the web page and change things about it and make cool things happen and animations and buttons that do cool effects and change things and browse away and bring you to this and that, etc. That's the awesome kinds of things that JavaScript can do. But we need to do a bunch of preliminary learning about JavaScript before we can even reach the point where JavaScript is messing around with your website and doing very awesome, amazing things in your website. So it's going to be a little while before, when we learn all of this JavaScript, we're going to see how cool, amazing things we can do in our web page and our website. For now, we're going to have to suffice with just seeing some things happening in JavaScript itself without necessarily the web page. Forget a little bit. Let's put aside a little bit the actual website. We're just going to focus on learning a bunch of basics in JavaScript. And as soon as we start applying that to the page, everything's going to fall into place. It's going to make a lot of sense. And you're going to start having a lot of fun with your web pages and make amazing things happen. So let's start by making anything happen at all. So one way how we could see the output, the results of programming, is to show something on the screen. In programming, there's this concept that you give it some input. It's called input. It's what you tell the computer. It's what you prompt the computer with. And then there's the output. There's the results that you see, right? Like if we open the calculator and I give it some input, 5 plus 5, I want to see some output out of this. And my output over here is number 10. That's what the computer gave back to me. So let's do something that shows us at least some output, something. So I'm going to use the alert command. If you open up your console, you type alert, and then you do an opening parentheses, and then you do an opening quote, and type, of course, traditionally, hello world. And then you type the closing quotes, and you type the closing parentheses. So why all these parentheses and quotes? We're going to learn all about it as we go. But for now, let's just make something that does something. And when you press enter in the console, after typing alert, open parentheses, open quotes, hello world, closing quotes, closing parentheses, you see this nifty little pop-up that says hello world. If you've ever been on a web page and they've shown you this kind of pop-up that said a message like, are you sure you want to browse away? Or this will now delete your account, or whatever like that. And you clicked OK. They probably use this alert command in their programming. Someone typed up alert, open parentheses, open quotes, you are about to whatever, blah, 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 and closing quotes, closing parentheses, somewhere in their JavaScript code. And that makes this pop up. So congratulations, you now made your first little programming hello world. You commanded JavaScript, please pop up a little pop-up that shows an alert. That's why it's called an alert, because you're alerting something to the person that's browsing the website, and you're saying some stuff in there. And anything you put between those quotes, the opening quotes and the closing quotes, as you see, will be the text that he shows in the pop-up. So you can go ahead and mess around with that, and you'll see whatever you type in those quotes, that's what he's going to show in that pop-up. Okay, cool. So we did one little programming thing. So aside from showing a little pop-up with a message, what else can programming do? So let's start with some basic concepts. Let's start with something called variables. So in a program, any program really, if you have a calculator program, if you have a computer game, if you have a browser, if you have a whatever it may be, it needs to have in it information. Like let's say if you're playing a game, there's the player's name maybe, there's the player's score, there's which level you're holding at, there is how many enemies are in the scene. If you're using like an address book application, then all of the information of each address, you know, the names, the addresses, the phone numbers, the last name indexes and where to find it. All of this is data. All of this is information that exists in your program. And you need to have some way where this information belongs. Where does this information happen? Where does it exist in your program, in your coding? So in JavaScript, this is done by something called variables. And variables, using the keyword var, which is short for variable, this is going to create for you basically a little box inside of your program. And you can put stuff inside of this box. And then later you can open up this box and see, hey, what did I put in that box? And then you could use that information for your program. For example, I'm now going to create a variable called score. Okay, so what I'm telling the JavaScript programming language, I'm saying, hey, create a var, please. Please make a variable for me, a box that exists in my program, and give it the name score. So it's like, imagine there's a label on the box. Now this box is called score. So anytime I'm going to tell the programming language, hey, what about that score thing? The programming language is going to know that I'm talking about this box that's called score. Okay, what do I want to put into this box? Well, now I could use the equals symbol, or as it's called, the assignment operator, and I could put stuff inside of the score box. So if it's a score, right, it's going to be some sort of number, like how many points did I get, or how many bananas did I collect, or whatever it is. So let's say I collected 100 bananas. I want to put the number 100 inside of this box. And that's pretty much it. And also for completion, it's not required, it's optional, but it's a good thing to do if you're consistent with it, is to finish off every command with a semicolon. This copies a little bit how other programming languages do it. Some people say the semicolon is over, we don't need to use it anymore. It's up to you. As long as you're consistent throughout your code, you can use a semicolon at the end of a line to finish a command. Okay. By the way, if you notice over here, the console over here, JavaScript responds to me with the word undefined. You can just ignore this for now. This is not important. We'll figure out about it down the line. But now we have a box called score. We have a variable called score in our program. If I type the word score, it's like me asking the JavaScript programming language, tell me about this box score. What's inside of it? And as you can see, actually, before I even pressed enter, this is a cool feature of the Chrome browser. It's a little bit preemptive over here. But he already tells me, oh, yeah, score, I recognize that. Inside of that is 100. If I press enter, it actually shows me the results, 100. If I type something else, like x, so x is a variable at this time. He doesn't have anything to tell me about it. So if I press x and I press enter, he's going to tell me error, uncaught reference error, x is not defined. I never created a variable called x. But I do have a variable called score. What else can we do if you have a variable called score? Okay, well, you could add some more to it. Let's say I collected another 10 bananas. So you can use some mathematical operations and add them up. Score plus 10. Now I'm having 110 happening. By the way, score is still the same. Score is 100. But when I did score plus 10, I got 110. This just basically combines whatever happens to be in the variable score with whatever I put on the other side of it. I can put any other number around it. I can put 90. I can put a very huge, insensible number. I can put in itself also, score plus score. And again, it just follows my instructions. Oh, you want to know what was 200 because score itself is 100. As you can see, this idea of a variable is that, if any of you might be familiar with this in algebra and stuff like that, you have like an x, right? Solve for x. You have in these equations, you put in the symbol x. And what that means is a box with any kind of number. It could be anything. It could be something else that you put in it. The mathematical equation will still work if whatever the calculations are supposed to be with it. So let's actually change what's inside of the score variable. Score equals 200. So now I changed what's inside of score. The programming language chucked out what was there before and put in the new thing that I told it to put into it. The 100 is not there anymore. Now it's 200. I can set it to 0. Let's say we lost, game over. And now score has 0 inside of it. I can do some more math with it. Score equals score plus 10. So now score is going to be 10. Why? Because score at first had 0. Then I said assign this number plus this number. Take all of that, whatever comes out of that, and put it inside of the score variable. Okay, so the compile, the console over here just follows my instructions to the best of its ability and puts that number inside of the score variable. If I do that same thing again, score equals score plus 10. Now it followed my instructions, and because it started off with already having 10, and I added another 10 to it, so now the score variable has the number 20 in it. So let's see some actual results from this already. I know that I can alert some text, and that is by saying blah, blah, blah inside of quotes. What if we alert the score? And you notice this time I did not use quotes around it. And now we see it's showing me in a pop-up over here the number 20. Whatever the score was, he's actually showing me inside of this pop-up. So what's going on over here? If I put score inside of quotes and I alert that, then it shows me just the word score. That's because when I tell the programming language to put something in quotes, I'm telling it, ignore entirely whatever it says inside the quotes, just take them verbatim exactly and use that as is. When I put it without quotes, I'm telling the programming language, pay attention to what I'm telling you. I'm referring to something specific. I'm talking about that variable that we were discussing before. And then the programming language has to look into its inventory of boxes and say, oh, score. Do we have a box called score? Oh, yes. OK, let's show score. Should we show the word score because I asked him to alert score? No, because since this is a variable gives out, it expresses, it yields what's inside of it, right? The whole idea of a box is not the fact that it's just a box. It's the fact that what's inside the box, that's what I'm referring to. That's what I want to use. And we can alert score plus 10. And then it'll show 30 because score is 20. And I'm doing some math on it and adding 10, then it shows me 30. Could we do alert X? Now we get an error. Uncaught reference, X is not defined. We never created such a variable, so he doesn't know what I'm talking about. Alert X. Can I do alert X in a string? And that, yes, he can do, because a string he's not paying attention to. This random sequence of whatever text I put inside there. It's called a string. I started using that word string without explaining it. String is just a fancy way of saying text. Anything you put inside of these quotes over here is a bunch of text or a string of characters. So when you do an opening and closing quote, that's just text that the computer is basically going to ignore and just use as is and not pay any special attention to it. Okay, so I do need to step out in just a minute. Label is going to take over with some Q&A. But what we've covered so far is we've just very quickly started delving into the JavaScript console in the browser, messing around with it a little bit, playing around with some of the features of the programming language. I also explained that it might not seem at first like, so what does that have to do with a web page? What does that have to do with a website? How can I make cool things happen from programming into the web page? And that's going to be coming to light a little bit further down the line. But first, we're going to get some basics of programming down pat. So we started with a little bit of variables. And yeah, so I'm going to step away. I'll be back very shortly.
Perfect. Thank you, Yisrael. So I'll take some questions. I see there's some in the chat. First of all, if hopefully you can hear me well. If you can't, then if somebody can please comment. Perfect. All right. So let's start with an interesting question here. Can JavaScript be styled? All right, so let's set the stage here. I know Yisrael didn't get too deep into JavaScript yet, but let's set the stage for what makes up a web page. So we already learned about HTML and CSS. HTML is the markup, the general structure of the page. Is this a title? Is this a table? What's the general structure? CSS is then style. What color should it be? How big should it be? Should it fade? Where should it be positioned on the page, etc. Then we have a new concept that we're jumping into today, which is JavaScript. What is JavaScript? So again, I think Yisrael probably went into some of this. JavaScript is a programming language. A programming language means that it is a way to write instructions and to tell the computer to do something, tell the operating system to do something, the program to do something. So you've been learning, what I see right now is a few very basic things. Some of them are, hey, tell the computer to take this number and add it to another number and then print it to the screen, print it to the console. Maybe you tell it to, hey, take this number and then do a loop. I don't think you learned about loops yet, but loop until 100 and add every time you loop, add another 20 to it, and print every time you add a new number. So the programming language is about writing actual programs that will do things based on logic. Maybe a better word is to create dynamic actions, right? So when you put HTML, you put the HTML there once and it's done. It doesn't change. CSS, you put the style there once, it doesn't change. How do you make things change, right? So this is kind of teasing. Yisrael already said he's going to get into this soon, so I don't want to get too far into it. But when you ask, can JavaScript be styled, that kind of misses the point of what the idea of JavaScript is. JavaScript is a programming language very similar to what Python is, Java, C++, C, PHP. These are all programming languages that allow you to create dynamic actions and to tell the computer to do complex things. So that's kind of the short answer. I think that question will become a lot more clear as you learn more and more about what JavaScript is. But just, I guess, one more point on this. Until now, we haven't really been learning programming languages. We've been learning markup languages, which is basically, hey, give instructions to the computer on how to display this, but not how to go ahead and do something complex. Not how to modify something in real time. Not how do I run a program that will then modify this page, right? When you go to Facebook, things are changing in real time. When you click on the like button, things actually change on the page. Something actually happens on the back end. There's things happening, right? When you just create a web page, it's just there. So JavaScript is what allows us to actually create new stuff. Dynamic content, dynamic things. All right, but I'm sure you'll get into it more a little bit later. Let's go back up here. How long does the browser keep the variable's value? Until I close the tab or until I close the browser. So this is a good place to introduce a concept called memory. You may not get into it too deep, but basically the idea is just you have different types of memory on your computer. You have hard drive memory, where you can store all your videos and all your pictures on the hard drive. Then there's more accessible memory. You may have heard of the term RAM, random access memory. And that's where things that are currently being used get stored, right? So if I have a Chrome browser open right now, all the things that are happening in Chrome, there's all this data, all this memory, all this stuff, it has to be stored somewhere on the computer. So that's stored in basically RAM, in memory that's very quickly accessible. It's very quick. It's much slower to get something off of a hard drive. That's disk memory, disk space, whatever you want to call it. So then there's also a concept of memory in the browser. And as you get closer and closer, or more and more narrow, memory starts to mean something slightly different. Again, I'm getting into a little bit of a complex concept here. But in short, the idea is when you store that variable in the browser, you're storing it on the page's memory, sometimes referred to as global scope. You can Google global scope if you want, global scope JavaScript. I don't want to get too deep into it, but in short, the answer to your question is when you refresh the page, if you put it in the console, if you refresh the page, it'll be gone. There are other ways to store things in the browser so that they stay for longer. There's a concept called local storage. You can put in local storage, you can put it in session storage inside of the browser, but that's a more complex concept that we'll get into a little bit later. But more or less the answer is if you refresh the page, it will be cleared. Or unless you rewrite the variable to mean something else. You can say score equals 1, and then you can say score equals 10, and then score will equal 10. But we're just at the beginning of our JavaScript journey. Can you do var score? Like score equals score? You can set score back to equal itself if you want, yes. Interesting. Okay. So this goes back to why A is explaining the original question about can JavaScript be styled. Yes, JavaScript can be used to manipulate the page and to create interesting styles on the page, but the way it's doing that is all with active dynamic programming where maybe while the page is open, you might you may have written some JavaScript that says, hey, if somebody scrolls down to this middle of the page, pop something up once they scroll to 1,000 pixels in and they're towards the bottom of the page or something like that. So if that was your question, yes, JavaScript can be used to create dynamic styling, for example, to pop up a modal, like a pop-up thing. Yes, Scratch that MIT is definitely a nice way to learn basic programming concepts like loops and when, if this happens, then do that. If some of you have ever worked with something like Salesforce, there are ways to basically use programming concepts even without writing actual programming, like if this happens, then do this. And while there are more of these records, do something else. So some of you may be familiar with these concepts from before. Elazar asks, are Java and JavaScript different? Yes, there are actually almost no connections between Java and JavaScript. I don't remember off the top of my head why JavaScript took the name Java in it. I think it was kind of a fluke for some random reason. JavaScript's actual name is ECMAScript, E-C-M-A script. Java has been around longer than JavaScript. Java is primarily a backend language, basically only a backend language. It's also used to create desktop applications, and Java for a long time has been the de facto way to create Android apps. So Java is primarily a backend language. JavaScript was for many years primarily a front-end language that just runs in the browser. More recently, they have adopted the JavaScript language to be used on the back end as well through a framework called Node.js, Node.js. But they're all basically the same concept. They're a programming language that tells the operating system to go and do stuff. Whether it's, hey, go run a web server so I can serve this HTML, CSS. Whether it's telling the browser, go find this element and make it disappear or make it pop up. So it's the same concept. If you learn JavaScript, it won't be so difficult to then go and learn Java. Although there are obviously differences. If you learn Python, it won't be so difficult to then go and learn JavaScript, etc. Good point. Somebody mentions that some people, when they write comments, there's different ways to write the comment. You can either send it to a panelist or to panelists and attendees. So when you write them, if you can please send it to everyone, panelists and attendees, so everyone could see the questions. Does every website use all three HTML, CSS, and JavaScript? In the early days of the web, it was just basically HTML and CSS. If you look at some of the very early pages of, for example, Amazon, there wasn't really any JavaScript on the page. It was just, hey, here's a listing, here's some books, and then when you click on something, it takes you to another page. There was nothing dynamic about the page. It's just, hey, here's a list of books, click on it, page reloads, goes to another page. There are still some websites, some very few websites that run just HTML and CSS. The pages load much faster if you leave JavaScript out. Some of these websites that you go to with a lot of ads, some of these new sites load extremely slowly because there's a lot of ads, a lot of JavaScript, a lot of things happening on the page. But things like a blog, if you go to like a WordPress blog, that's more or less just HTML and CSS, very little JavaScript. Basically, the server is just serving up the page. This is what it looks like. It serves up the whole page, and there's very little JavaScript, if any. So you can definitely have something like a blog, WordPress site without any JavaScript on it. About Java and JavaScript, I think is the question from Elazar. Are both Java and JavaScript popular and useful? So Java is primarily, oops, looks like we lost. Java is primarily used as a backend language, and it's usually used in very big companies with a lot of scale and a lot of traffic. It's very good at handling a lot of traffic concurrently. At my company, we use Java as the backend. There's a lot of extra things you need to think about in Java. If you really want to go down the rabbit hole, you can Google something called multi-threading and compiled languages. But yeah, it's definitely very popular. Google is mostly based on Java. JavaScript, though, Google's front end is all JavaScript with various frameworks. So yeah, it's definitely, both are definitely very popular, but they have different use cases. Can you still find the query by just using HTML and CSS without JavaScript, or do you need JavaScript as well? If you want to be a web developer or a programmer or a software engineer, you have to know at least one real programming language, like JavaScript, like Python, like Java, something. If you just know HTML and CSS, you will not be able to be hired as a web developer, programmer, engineer, software engineer, any of those terms. You can use them as you like. You may be able to get a job as a designer that is able to make some edits to the front end, or even a front end developer that primarily, if it's you can probably easily get into doing some WordPress customizations. There's a big market for WordPress stuff, and WordPress is mostly HTML and CSS. So yes, it's very useful, and there are some jobs, but to get a job as a software developer, a web developer, whatever you want to call it, you're going to have to know a programming language. Good question. If you can find open source HTML online, why would you have to write it from scratch? So it depends what you find online, right? If I'm creating a blog and I say, or I'm creating a deal site, right? Which is a lot of what we're talking about here. So you could say, hey, you know what? Why don't I just go to dansdeals.com? Let me copy his whole HTML and CSS, paste it on my site, and I'll just use my back-end programming to just throw in some deals here and there. Maybe he'll sue me. It's probably unethical because he did not leave that as open source. Now, if your question is, okay, now your question may be, what if it's actually open source, it has an open source license, and they're happy to let you use it? So then by all means, you can take that code and use it. There's a huge market for HTML and CSS templates, landing page templates, all that kind of stuff. So you can most definitely do that. We have a few people raise their hands for questions. Oh, Yisrael Goldstein raised his hand. Sorry about that. Not sure why we lost him there. So yes, if you do find HTML on the web and it has an open source license, by all means use it. But in most cases, you will not actually find exactly what you need. Usually you're going to need some customization, and sometimes building yourself, rolling your own, is a lot easier than trying to customize something that someone else already created. So that's more or less. But yeah, how do you know if it's open source? It depends where you find the code. If you find the code on somewhere like GitHub, it will usually, if it's proper open source, it will usually include something like a license or something like that. So yeah, if you find some nice HTML, also I think if you find CodePen, for example, has a lot of just nice templates and stuff that people do. I'm pretty sure everything on CodePen has a free to use license. Somebody can double check on that, but I'm pretty sure if you find stuff on CodePen and you want to include it in your website, if you find some nice animation or some nice thumbs up, thumbs down feature, you're more than welcome to use it, as far as I know, but you can double check on that. All right, that's all I got for now, and here, back to you, Yisrael.
Excellent. Thank you very much. Okay, so let's get back to this over here. Okay, I think this might actually become a little bit more pertinent and easier to grasp and more interesting if we put ourselves a little project, a little goal here that we want to make with this, and then this is all going to make a lot more sense. So let's say our first goal here, even though it's not very big, fully featured and fancy just yet, it's a little bit of a modest mini thing to make, but the big strides start with the little baby steps. So let's start with, we're going to try to make a little game. I'm going to see if I can even succeed, even just tonight, within the remaining time that we have now, to try to make, with programming, a little number guessing game. The simplest form, which is that you think of a number in your head between 1 to 10, And the computer, the program that you are going to be programming, is going to try to guess the number that the human user is guessing. So the way this works in the human form, and probably a good analogy of how to think of programs, a good example that we have in real life is when you have the instruction manual for games. Like if you buy a new pack of Uno cards or a new board game or something, and you read through the instructions over there, I think that's a very good example of something that's like a programming language kind of thing to do. And let me demonstrate what I mean by that. Let's open up an empty file over here, and let's type up in English, in the language that we understand, the guessing game. Okay, number guessing game. We're just going to type this in plain text in English. So, number guessing game. Step 1. Player 1, which we will call we'll call him the player. Think a number between 1 and 10. Okay. Step 2. Player 2, who is the guesser, ask the player a number. Step number 3. Player responds with hints higher and lower. If guesser guesses the right number, the round is won. The objective is to see in how few turns guesser can guess the player's number. Okay, so here are the instructions for a game. Okay, it's a very simple, basic game. It's not too fancy, and you'll find much more complicated instruction manuals for, you know, board games and much more complicated games. How to play hide and go seek, how to play whatever, right? Battleship, how to play chess. Those are much more complicated, many more detailed situations over here. But this over here is a very basic kind of game, and we're going to try to do that in programming here. How would you make a program like this that you can actually genuinely play against, and you could really think of a number, and the computer is really going to try and guess your number? So for that, we're going to need to have a few things. We're going to need to have some memory, so to speak, in the computer, so that the computer remembers what number is he thinking of, what number is he guessing. All right, I'm really, really sorry about that. I'm actually having some connection issues. Let me try once more to share the screen and get back on track over here. Again, I really apologize. I'm actually experiencing some connection issues tonight. I hope it doesn't occur anymore. Okay. So we need to have some pieces of information that exist in our game so that we can keep on playing it, so that we remember what we guessed already, which one is it higher of, which one is it lower of, and then we'll be able to you know, to carry on this game without losing track of where we're holding. And for that, we can have one of these boxes in memory that are called a variable. Let's say we're going to call this variable guess, because it's the number that we're guessing. So let's say to begin with, if we want to try to have a good calculation, right? What is the fastest calculation you can do to try to guess someone else's number from 1 to 10? Or really from any to any other number, but let's start with thinking smaller. So if someone is guessing a number from 1 to 10, what seems to be the fastest calculation is divide and conquer, right? If there's 5 numbers here and 5 numbers there, and it could be any of them, then let's split it in half, and that, that divides your chances by half. If you started off by guessing, is it number 1? Then you're going to have 9 more numbers to go. But if you start off by guessing, is it number 5? Then whatever the player is going to say, you have to go higher or you have to go lower, then he already eliminated as many other possibilities as possible. So 5 is, for example, is a good first number to start guessing with, always between 1 to 10. You can do 4 if you're counting 0, whatever it is, or you can do 6 if you want to be on that side of the 5. But generally, let's say 5 is a good starting point. If he says higher, then it can only be 6, 7, 8, 9, 10. If he says lower, then it can only be 1, 2, 3, 4, 1, 2, 3, and 4, and 0 if you're also counting 0. So we're creating a variable called guess. Okay, so now let's say we want to let the user know, I am guessing 5. Is it 5? So I'm going to alert to the user. I'm going to alert to the player. I guess number 5. Okay. All right, great. So we have at least a few steps over here. We have a variable, we have a box that remembers what we guessed, and we are telling the message the following text, I guess number 5. But now here's what's going to happen. As the game progresses according to its instructions, we're going to be doing a certain step over and over again. If I say number 5, and the answer is higher, then I'm going to guess another thing. Now I'm guessing number 7. Now I'm guessing number 8. Now I'm guessing number 9. So when I'm saying whatever it is, the number that I'm guessing, I want to be able to say not just always some exact message that I'm talking about. That message is going to change over time. Alert, I'm guessing number X, so to speak, if there was some way to express that, right? In one turn, I'm going to be guessing number 1. And another turn, I'm going to be guessing number 5, number 7, number 8. So how do we actually do that so that as the game progresses, some games are going to go on for 2, 3, 4, 5 turns. Some games are going to go on for only 1 or 2 turns. Whatever it is, and whichever numbers, sometimes it's going to go up, sometimes it's going to go down. How am I able to show to the person playing the game whatever the variable number may be? So actually, as it turns out, you can combine different things together in programming, and it'll kind of smush them together. And that is actually done with the addition operator. You do the plus symbol. The plus symbol usually mathematically means to do addition, right? 1 plus 8 equals 9, right? But over here, when we're dealing with text, when I'm writing a message, a string of characters such as blah, 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 then the plus symbol basically just smooshes together, it combines together more stuff. So let's say if I have one bunch of blah, 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 and a second bunch of blah, 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 and I add a plus thing in between them, you can already see the results that Chrome is preemptively showing me on the bottom over here. He's showing me both of them combined together. And there you have it. What we did was we took one thing and we combined it together with another thing and put them, both of them together. It doesn't necessarily make mathematical sense, but a little bit. It kind of means this plus this equals the results of putting both of them together. So how is this useful? Because you can do this also together with your variable. You can do a message such as, I am guessing number, close the string, use the plus symbol, and then use the name of your variable. And you can see the resulting message is showing, I am guessing number 5. It's actually missing a space over there. So let's go back up to that command. I'm going to use my up arrow symbol on my keyboard, my up arrow key, and it's going to bring me back to the previous command that I typed into the console. It's a convenient, useful little way how to not have to type the same thing over and over and over again. But I just press the up arrow, and that brings me back to what I typed before. I'm just going to go back and add a little space right after the word number. You see, the computer, the programming that happens on the computer is very stupid and very exact. You told it exactly what to do, and it's going to do exactly what you told it to do. If you told it to show this message on the screen, whatever is exactly between the quotes, the letter I, and then the character space, and then the letter A, and M, and space, and G, etc., etc., it follows everything exactly. If at the end of the whole phrase, you just told it, okay, and then B, and then E, and then R, and then I'm done, and then you say, oh yeah, and tack onto that as well, add onto that the variable guess. Then it's going to literally do just that. Hey, this is what you told it to do. You said, do I am guessing number and 5, and then it put them both together. It's not that smart to figure out on its own, oh, you were trying to write human readable text, and the text should have a space between each other, especially since I typed a space over here. You see, after the closing quotes, there's a space, and there's another space over here. So shouldn't the computer figure out that, like, come on, you know, be reasonable with me here. I am guessing a number, put a space in there, you know, but the computer follows exactly what you told it to do. You told it to show this message, it's going to show exactly this message, followed by whatever you told it to combine together with that. So if I wanted to have a space in there, you got to tell the computer to add a space in there, and then it follows your instructions. Let's say now I change around what the number of guess is. So I'm going to say guess equals 7. Now, if I show the message, I guess number guess, suddenly the result is I am guessing number 7. So you can see you can change the contents of the variable guess, and it has an effect in the program that now this is the score, now this is the number, now this is the guess, now this is the age, now this is the, you know, whatever it is, the counter. Anything that you put inside of a variable stays in that box, and you can play around with it, and you can change it, and you can use it later on in your program. So let's see, what else can we move on to over here to make our little guessing game? I am guessing number, and then you tack onto that a variable. By the way, I would strongly encourage, again, as usual, in order for these ideas to take hold and to really be understood, and for you to get used to them and understand them and really absorb them, try these out. Maybe even try these out right now as we speak. Just literally do exactly what you see I'm doing. Do it yourself as well. Type alert is exactly like that, and type some text inside of these quotes and close the parentheses. Even just doing it physically yourself is an important exercise to just start getting into it, getting familiar with it, and starting to really do it. So let's go back to our program design in a way, our instructions of how our program is supposed to work. And let's figure out how this is going to work. In order to make it simple, in our program, it's going to be in one direction. It's not going to be in both directions. You can do that yourself eventually in the future. It's a bit more complicated, but we're going to do it in such a way that the person playing the game is the one who is thinking of a number. So the human person using the computer, using your JavaScript program, he is going to think of a number from 1 to 10, and the computer program, the JavaScript, is going to try to guess what the human's number was. It's not going to work in the other direction. For now, it's just the computer is going to say, I'm guessing this number, I'm guessing that number. And you have to tell the computer, is it higher or is it lower? So while we're talking about variables, let's look into a few more interesting things you can do with variables. As we've seen, we can do some math. So in addition to doing guess plus 10, we can do guess minus 10. And now it's a negative number, actually. We could do guess times 3. So I'm using the asterisk symbol here. In programming, the asterisk that's the multiplication symbol. So guess times 3. 7 times 3 is 21. You can do division, of course. Guess divided by 2 equals 3.5 if guess is number 7 at this point, because in the beginning it was 5 and then we set it to be 7. So now it's 7. 7 divided by 2 is 3.5, 3.5. Now if you realized, what I did so far did not affect the box. It didn't affect the guess variable at all. I just did mathematical expressions, right? Just like I can type 1 plus 1, okay? And I can type, 34 plus 6,666, right? I can also type guess plus whatever. But all that does is it tells the program, it tells the JavaScript, just think about that number. Just tell me the results of that number. But we didn't necessarily instruct the program, go and change what is inside of the variable guess. This is an important distinction to figure out, and you'll see as you're playing around with it. Sometimes you're just using what's in the box. Hey, computer, tell me what you stored inside of guess. Now add that to this other number, and you basically just took out just to read what it says in the box, what it says in this variable guess. But other times you're going to be doing commands and operations that actually changes what's inside guess. That's with the assignment operator, guess equals 10. Now I changed what's inside the guess variable. So now when I do guess times 3, it's no longer 7 times 3, now it's 10 times 3. And the result of that is 30. And again, when I did guess times 3, that didn't change what's inside of guess. That just used it for a mathematical operation. I can change what's inside of it, though, by saying guess equals guess times 3. So what this does is, first it's going to go over here and see, okay, I see the number 3. I see you want to multiply something by 3. I see you want to take whatever is inside the box, the variable guess, and you want to multiply it by 3. Now, what do I do with that? I want you to take all that and assign it, using the assignment operator, assign the results of that inside of the variable guess. So you're taking this stuff, whatever results out of it, and it could be anything. It could be a big mathematical number with addition and subtraction and division and who knows, whatever you want to do there. And it takes all of that results and it says, and now actually put it inside of this variable, put it inside of this box, guess, and that changes what's inside of that box. If you don't change what's inside of the box, it's going to keep whatever it had before. Now, having said that, let's go a little bit further with what you can do to change what's inside of the guess box. Here's something interesting that often happens in programming. For some reason or other, it happens a lot of the time that you want to change what's inside of a variable by just 1. You want to add 1 to it. So let's say whatever the variable has, whatever number is inside of it, which at this point happens to be number 10, but it could be it has number 8 in it. Maybe one day it has 1,000 in it. Maybe one day it has 10,000 in it. Whatever number is inside of it, let's say you want to say add another point to that. Let's say we're talking about score, okay? Oh, the player just gained another point. So whatever score is currently in there, which we might not know at any given time, it could be any number. Now just add a number 1 to it. So the very kind of drawn out way how to do this, which we already know by now based on what we learned, is we say, okay, score equals, we're going to assign something into the score variable. Take whatever it has inside of it already, score equals itself, plus 1. Okay, so take whatever itself already is, and then add 1 to it. And then take the results of that and actually change itself. So if before it was 10, now it's going to be 11. If before it was 30, now it's going to be, if before it was 20, then now it's going to be 21. So this is kind of the long drawn out way how to do that, by assigning the results of a mathematical calculation like that. But there's also another interesting operator you can use, score plus plus. And now that increases what is inside of the score variable. If I examine what's inside there, hey, JavaScript, show me what's inside of that variable. Oh, well, what's inside of that variable now is 22. Interestingly, before that, it shows us 21. This will become more apparent later when we explain about the difference between plus plus score and score plus plus. When you do it beforehand, it does one thing. When you do it afterwards, it does another thing. But you know what? Let's just work with plus plus score for now. Plus plus score, you know, it's not the common operation that you find on your calculator. You know, if you go to calculator and you press plus plus, it's not going to do this. But in programming, when you do plus plus, it adds 1 to whatever the number is. So if you have a box that inside of that box you keep memory, the data of your program, you keep some number, and now you say, please add one more number in there. Whatever the number is in there, add 1 to it. So you can do that easily with plus plus score. You can, of course, spell it out and type score equals itself plus 1, which also works just as fine. Or you can just do much more shorthand, plus plus score. Okay. What are some other things you can do? Guess what? You can do minus minus. That'll reduce it by 1. Sometimes you want to add or remove from it a bunch. So you can do score plus equals 3. So that has the same effect as saying score equals score plus 3. Instead of doing it 1 by 1, it does it by whatever increment you want to do with the 3. What else can you do? You can do things like score minus equals. You can do probably score times equals, I think. Let's see if that works. Yep, that just multiplied it by 8 and actually put that number inside of the score box. And these variables are containers of information that you're going to have throughout your whole program. It's going to keep track of information of your program. If you have someone's name, like for example, var, right? To create a new variable, we have to use the var keyword. Hey, JavaScript, create a new variable for me, a new box. Let's call this box name. Actually, let's call it var first name. First underscore name. So variables have certain limitations of what you can use to call them a certain name. You can only use alphabet letters, you can only use number digits, and you can use the underscore, and strangely in JavaScript you can also use the dollar symbol. But other than that, you can't just use anything else. You can't use a dash, you can't use a plus or equals or whatever. That can't be part of a variable name. It can only be alphanumeric. It must start with a letter. It can be uppercase or lowercase. You'll get used to this as you go already. But let's say if you start creating a variable like this, like a variable my name, yeah, you're going to have some problems over here because it needs to be all connected. There can't be any spaces between the name of a variable. It all has to be in one chunk. But you already figure this out as you go. So let's say I create, my program has to do with people's names, people's addresses, stuff like that. How do I keep track of someone's name in my program so that maybe I could show it to the user? Maybe I could put it into the page. Maybe I can change it. I can update it in the database. So you're going to create a variable called variable first name. And my name equals Bob. So what's going on over here? It turns out until now we were just playing with variables containing numbers. We did a score that contained 10, 20, whatever. We did a guess, which also contained some number from 1 to 10. As it turns out, you can put into a box, you can put into a variable, into a piece of information in your program, also this kind of message, this kind of text, string. You can say my first name is Bob. And it could be anything, right? Could be also Doe, etc., etc., whatever the name of the particular person might be. Now let's try to alert this. Alert whatever is inside of the variable first name. And it alerts over here. It's a little bit small. I don't know if you guys can see clearly. I wish there was a way how I can zoom into the actual alert box here. But it's showing Doe. It showed me the name that I put into this variable. So it's interesting. I could either alert Doe, and that shows Doe, but then I directly, verbally, expressly said the name Doe. Sometimes I'm not going to know what the guy's name is. It's going to be as part of the data of the program. So instead, I can alert the variable first name, and whatever the guy's first name is, it could be it's a different thing for every person that runs this program. They're all going to see individually their own value that's in that box. So we're trying to make a game where you guess a number. So let's say we have our guess. Let's reset it back to what it should be. Guess equals 5. And let's say we alert to the person using our program. Hey there, I'm guessing, or maybe let's use the phrase, is it number? And then let's put in there plus guess. And just to make it slightly fancier, I'm going to add even more text after that, and I'm going to add a question mark. So now this looks a little bit more like I'm asking a full phrase. And as you can see, we're instructing the programming language. Please do this alert thing. We're going to learn a little bit later what functions are, and it has the keyword, and it has the opening parentheses, and it has the closing parentheses. Don't worry about that for now. But now all this means is we're going to command the computer to do the pop-up command. Show the person this alert pop-up thing, and inside of there, the text you should show them is it number, and then whatever the number is that we're guessing, followed by another question mark. How are we combining this all together? Using the plus symbol. Plus takes something, combines it, and squishes it together with something else. And you can even go on and on like that, squish it with something else, squish it with something else. Everything together is going to result in one long text that is going to show. So we're asking the computer to say, please show now, is it number something question mark. Let's see if that works. Pressing enter. Is it number 5? Now we need to have some sort of way how to get the user to answer us. So we've given some output to the user. The person using the program sees something. They're getting some information from the computer. The computer is able to tell them something. But now we need to get some answer from the human back into the computer for the computer to work with. So for that, we're going to use another magic thing. By the way, I keep pressing this button over here, the clear console, so that it clears out whatever else we might have going on over here. If this is getting filled up and I need some space, I click clear console and it cleans the whole thing up. So we're going to use something similar to the alert pop-up, but this one's a little different. This one is called prompt. Prompt is very similar to alert in that it shows a message up on the screen, but this time also it actually asks you to answer it, to give it something back. Please type something. Okay, so what is it going to do? I'm going to press enter and let you guys guess and try to figure out what this is going to do for a second, and then let's see what that means. So I'm going to press enter now. Now we have a pop-up that says, please type something, and there's an input field with a blinking cursor asking me to type something. And I can type something, and I can either click OK or I can click cancel. What happens if I type something and then I click cancel? Then, interestingly, we get this response back from the prompt that tells us null. Null, as we're going to learn, is one of those things that JavaScript tells us when it says, I got nothing. This is empty. This is void. I could have gotten something, maybe a number, maybe a piece of text, maybe a piece of information, but instead, this is empty. This is nothing. Let's try it again. Let's try to do something else now. What if I give it something? It's asking me to type something, so I type something. Press OK. Now we're seeing, interestingly, here in the console, JavaScript responded to me with the results of what was typed in. Anything that was typed into that prompt, now we have it in JavaScript. We have it inside of the program, and we can do something with it. So for example, if I say, you know, this is a phrase, we get this is a phrase inside of our program. Now, unfortunately, this fleeting phrase over here has flown away and disappeared because we didn't do anything specific to it. We just basically had it for a second in the program, but then it just disappeared into the ether, into the void of programming. Instead, what we can do is we can grab it and put it inside of a box so that we keep it as a piece of information in our program. And we already know how to do that. We want to create a variable, the variable which will contain inside of the box the answer that the user has given us. So instead of prompting something to the user, then typing something in, and then us losing that because it's just like, oh yeah, they typed something, but it just disappeared. Instead, we want to grab onto that in the programming language and stuff it inside of a storage box so that we keep it in our memory, we keep it in our programming, and we can use it eventually afterwards. So let's make a variable called answer. Okay, so now we have a variable called answer. We can put something inside of it. We can put some numbers in it. We can put some text in it. But what we want to do in this case is we want to put inside of it whatever comes out of the result of prompting the user to type something. So right now, I can put something in it myself. As the programmer that's typing the code, I can manually put something in myself. So now if I type answer, it has that text inside of it. If I alert answer, it'll show the text that's inside of that thing. Let me just get my highlighter over here. Okay, right? It's going to show what was the results of opening up that storage box and seeing what was put inside of it and showing that on the screen. But what I really want to do is I want to take what comes out of prompt when I ask the user to please give me something, and whatever the user is going to type in here, I want that inside of my answer variable. I have here a box that has in it a bunch of stuff, and I want instead to take whatever the person is going to type and put that inside of this box. Can anyone figure out, answer me in the chat, I'm going to open up the chat real quick. Can anyone figure out which of the symbols that we've learned about so far can we use to take a piece of information and put it inside of a variable? We've done it a few times. When I wanted to put a number inside of a variable, when I wanted to put a different number inside of a variable, when I wanted to change what's inside of guess, when I wanted to change what's inside of what was it, score, right? We use a certain symbol to take some information and put it inside of a variable. So I'm seeing some answers in the chat that are telling me, very good. Okay, yes, I see some of you guys figured it out. We use the equals symbol. Equals is the assignment operator, which takes something and puts it inside of a variable. So I have my variable that I want to fill it up with the results of what comes from the answer. I want to use the assignment operator, and I want to put inside of it what comes out of prompting the user for something. So as I see someone answered correctly over here, the way I have to combine this all together in this case is to put the prompt right after this. Prompt, give me something, right? Just like we were able to put inside of this box a number, and now answer has a number. And we put inside of this box some text, and now this box has that text inside of it. Anytime I call this box, hey, box labeled answer, what's inside of you? I have exactly what I was put inside of me. So the same thing we can do, answer equals, and we put over here whatever might be coming out of the prompt that the user is typing. Now the programming language, JavaScript, is going to go and do the pop-up and prompt to the user, give me something. And then whatever comes out of that interaction is not just going to disappear into the program, because we commanded the computer, take whatever comes out of there and put it inside of my answer box. So let's see if this works. Give me something. I'm going to put a whole bunch of Qs. And now we've got that bunch of Qs showing inside of the console. Let's see if that's actually the case. What is inside of you answer? I remember before when I typed answer, it had number 7, it had a bunch of gibberish. What does it have now inside of it? The text that came out of prompting, because we took that and we assigned it into the variable, into the box of answer. And we can play around with this. We can do answer plus more stuff. And that will give us whatever was inside of the answer box plus whatever else we combined with it. We can alert this. Answer. And remember, don't forget the difference between if I alert answer or if I alert answer with quotes, right? If anyone remembers the difference, one of them I'm telling the computer, go into that storage box and see what's inside of that answer variable. And in the other one, I am telling the computer, just show this text on screen. Just whatever this text is, take it literally verbatim and just show it on the screen, and that's going to show the word answer. And we can do combinations of these things, like your, whoopsie, this has to be a message. your answer was, and then I'm going to combine this with whatever answer was. Your answer was Q, 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 Q. That's what we typed in before when we were prompted. And what we were doing now so far, and what happens generally in the console, is that we type in one command, and the one command happens. And then we type in another command, and then that command happens. One by one. Instruct the computer does it right away. Really, what we're going to be doing with programming is very similar to when we were typing up HTML and CSS. We're going to be writing up a whole list of instructions for the computer to do, and the computer is going to execute them one after another sequentially and correctly, depending on the situation. If it's supposed to do this, it's going to do this. If it's supposed to do that, it's going to do that in the correct order. So let's simulate that a little bit here. I want to do a few commands, one after the other. I want to create a variable called answer2. Okay, and I'm going to give it the number 0 for now. Okay, so I created a box called answer2, and I put in the value of 0 inside of it. Then I want to tell the computer, show a message on screen that says, we started off with, and then I'm going to add into that whatever may be in answer 2, which we happen to know at this point is 0, because just one line before we put 0 in there. Now I'm going further to the next line. What I'm doing here actually is when I usually type a command into the console, I right away press enter. Enter executes your program. It runs the program. But what I'm doing now is I'm holding down the shift key on my keyboard, and I hold down shift and I press enter. It doesn't execute the command yet. It tells me, oh, I think you just want to go to the next line and you want to keep typing more stuff before this gets submitted to actually be run in the console. But this is just a side effect of how it is working in the console. This is not how it usually works with programming in your web page with JavaScript. We're going to get to that soon enough. But for now, we wrote one line of code over here, creating a variable, and we put the number 0 inside of it. We're going to show that message to the user that's using our program and say, hey, we started off with whatever it is inside of answer2. Then we're going to prompt and say, give me something else. And then the user is supposed to type in something else. Then we want to take what comes out of prompt and we want to save that in answer2 equals. So now whatever comes out of prompting, whatever the person is going to type in is going to be put into this box. So gone will be the 0 that was in there before. Now instead it's going to get replaced with whatever is being typed in. And finally, let's finish our little program over here with alert. You gave me, and then we're going to type answer 2. Okay, so if we're trying to think a little bit like the computer, which is important to do when you're doing coding, when you're doing programming, always ask yourself, what am I thinking that the computer is going to do with this? Is he going to understand this correctly? How is he going to go through this? And is this going to make sense to him? So let's read through this as if we're the computer. First, create a variable. Put 0 inside of it. Next, show a message to the user with this string of text, this text message over here, and then add on to that also whatever might be inside of the variable answer2. Then change the answer2 variable and put inside of it whatever comes out of prompting the user with give me something else. Whatever the user is going to type in is going to be assigned using the assignment operator into the answer2 box. And finally, the last step of our program, we're telling the computer a message, you gave me whatever came out of that variable. So I'm going to press enter now without holding down shift, which should actually execute the program. And let's see how it goes. All right, so it ran already the first step. It ran it so fast that we weren't even able to see any effect of that. It created a variable and it put 0 inside of it. But now we're seeing the second step. He already finished this part and he already moved on to here and already is showing an alert that says, hey, we started off with 0, because that's what we had in that variable. All right, I'm going to click OK. Let's see what it goes on to next. I'm being prompted. Give me something else. So now he's executing this part of the program. Okay. 2, 3, 4, 5, 6. Okay, I'm going to click OK. And finally, he's executing the last part of this program. You gave me 2, 3, 4, 5, 6. That works very nicely because when we prompted us to get something from what we type in, we already saved it into a variable. And now we use that variable over here that whatever is inside of it is going to get used in the program. So we see a few things from here. We see how a computer executes a program. You give it instructions, you give it a sequence of instructions to do. First do this, then do that, then do that, then do that, and it goes through it one by one and it executes them. We understand how variables work, that a variable is basically a storage box that you can put inside of it different pieces of information that you're going to be using inside of your program. You're going to be using a lot of variables in your program all the time because you need to keep track of a lot of pieces of information on various aspects of your program, of your web page, of whatever it is. And variables is how we do that. And then we saw how we can use variables, change what's inside of variables, and express what's inside of variables by showing messages to the screen, asking the user to put some stuff inside, and then showing the results out on the screen. Let's learn one more little important thing over here. Programs are very prone to having bugs. Whenever we do programming, we're inevitably going to make mistakes, we're going to make problems, and there's going to be issues coming up, sometimes that we haven't even anticipated at all. For example, this program seems to work pretty simply, right? I just start off with a variable with a number, I show that to the user, and then I ask him to type in something else, and then I show it back to the user again. What could go wrong here, right? Seems simple enough. Well, it turns out we haven't accounted for every single possibility. There could be some problems happening over here. Let's try it. I'm going to run this program again. I pressed the up arrow again, so it gave me back all this code that I already typed before. Now I'm pressing a real enter to execute this program. Okay, we start off with number 0. I'm clicking OK. Give me something else. How about not? How about I give you nothing, and I'm going to click cancel. I haven't thought about this case before. So I'm clicking cancel. And now it says you gave me null. As you remember, null is this idea that the programming language says, I got nothing. Usually there should have been something here. There should have been a number or a value or something that you can put inside of a variable that I could use over here. But when I click cancel, the program was supposed to take what comes out of prompt and assign it and put it inside of this box. And then we're going to use that box over here and take out whatever is inside of it. But instead of putting in an actual something and clicking OK, I put in nothing and I click cancel. The result of that is that answer 2 now has big old void nothing inside of it. Because I did execute this command, the computer did follow my instructions and did put something inside of answer 2, except that something is nothing because nothing came out of the prompt. And I took that big old nothing and put it inside of answer 2. And now we're seeing the results of that. And instead of showing a nice, coherent, correct, fixed program that looks very fancy and looks very presentable and says, oh, yes, you gave me something beautiful. Instead, it's showing me something ugly. I put in a nothing, and now it's showing this technical term null, which is like, hey, what is that? That looks like something's broken. It looks like there's an error over here. So this is something to get used to in programming. There's going to be a lot of situations that you create with programming, which you thought you covered all bases, but really you haven't. There are mistakes that happen, there are errors that happen, and the mission in life is eventually to try to get as good as possible, more and more, to find these issues, cover them, try to think of all the different scenarios of what could happen, and then deal with them. There are ways, for example, how to deal with this. If someone goes ahead and puts nothing, there is a way how to tell the program how to deal with that. If I click cancel, the program can check to see first, did the user type something in, or he didn't actually type something in? If he gave us something sensible, then go ahead, proceed with the program. If he didn't, however, then maybe show an error message or say, oh, you gave me nothing. That's not good. Please try again, or something like that. So those are scenarios that we can account for, and we can program as we go along. So we're still trying to make a number guessing program. We need a few ingredients to get there. Variables is one of them. Showing a message to the people on screen is another one of them. And we're going to need a few more ingredients that we're going to learn as we go further. We need a way to check what number it is and what if we need to go higher or if we need to go lower. We need to figure out how to ask the question, if we need to do this, then do this. If we need to do that, then we need to do that. That's something called a if statement that we're going to learn about very soon. But just for now, because of our homework is going to be revolving around practicing JavaScript and exercising variables and what you can do with variables and how you can show the results of those variables on screen with doing alert and doing prompt and stuff like that. Let's finish a little bit more of what we can do with variables. My variable number one, let's say equals, what else can we do? We can do a number that has fractional parts, right? Until now we did only whole numbers, which are sometimes called integers. But now we're going to start looking at, I can do 0.5. So this is often called a floating point number because it can have a point in it, and that represents like fractions of a number. So I can have 100 or 1,000.50093. And now this is a number that has a fractional part in it. We can have negative numbers, as we've seen already. We can have, here, let's examine to see what's inside of my variable. It has that negative number. We've done most of the operations that we can do with variables. Let me try to quickly think. We've done addition, subtraction, multiplication, division, and we can do all of them as much as necessary, however we want to do. The program is just going to try and follow whatever you tell it to do, plus this, minus this, times the other. It could work with numbers very, very well. Any mathematical stuff you need the computer to calculate, it can mathematically calculate for you, no problem. Then we can put in strings we saw already. That's the text messages. We can put in combinations of strings, combinations of text, like this plus something else. Let's quickly look at one more little detail over here, and I think that'll be all the time we have for now. Who can discern what is the difference when I say alert a string, a text of 5, and if I do alert not the text, not the quoted string of 5, but rather just 5. Both of them seem to show me the same thing. Alert 5 with quotes, alert 5 without quotes. What's the difference? Well, let's see if you can figure out what happens if I want to alert 5 plus 5. Or what if I want to alert 5 plus 5? One of them being in quotes, one of them not being in quotes, both of them being in quotes. So usually what happens with mathematical calculations is if I say 6 plus 6, I'm going to get 12. If I do 5 plus 5, I'm going to get 10. It actually does the mathematical calculation for me. If I do alert 5 plus 5, I should be getting 10. If I do alert 5 plus, whatever, 6 plus 6, I'm going to get, he's not going to show me a 6 and then another 6. He's not going to show me the plus symbol. He's going to first calculate this calculation, and whatever the results of that is going to go into the alert. That's what the alert is going to show us. But now what's going to happen if there are quotes around it, if anyone can guess? What is it going to show me if I do alert 6 plus 6, and this time it has quotes? Very good. For Bear Baumgarten, who answered in the chat, it's literally going to show the digit 6 followed by the digit 6. And if you make this mistake sometimes with actual numbers, with actual variables in your program, you might sometimes get confused. Like, it looks mathematical, right? I gave him a number, I gave him another number, and I got a number. So it almost looks like he did the math. It's just that the math is wrong. How could it be that I'm giving in one thing and another thing, and then he gives me this, which seems like it should be right, but it isn't right? And this is a bug that sometimes happens in programming, and it's hard to figure it out because, again, you gave it a number, which seems fair, and it answered you back with a number. But what you didn't realize is that you gave it a string, you gave it text, and you told them to put them together with a plus symbol. You didn't tell them to calculate it mathematically. And this is going to become a problem where we're going to be asking the user, give me a number, or tell me if it's more or if it's less. Or if the computer asks you, give me a number that I can do some math with, right? Let's say we want to do first number equals 7, okay? And then second number equals prompt. Give me a second number to add. And then we want to add both numbers together, right? So we're innocently thinking, oh, great. We made a first variable and we put the number 7 in it. We're making a second variable and we're going to put in it whatever the guy is going to type in, right? Oh, wonderful. Give me a second number to add. I typed in the letter A twice. Sorry about that. So let's say I'm actually a good boy, and instead of typing a bunch of text, which is another error that can happen over here, let's say I'm actually a good boy and I type in a number, 10. We have still another problem going on over here. If we evaluate what's in second number, we see a string of 10, and it's not a number of 10. So if I'm trying to be smart and say, okay, alert, first number plus second number that we got from the user. Yay, I'm going to add up his number with the number 7. And so if he types in number 10 plus number 7, it's going to be 17. Wonderful. I'm so happy about that. What is going on here? Why does it say 710? Exactly. Because one is a number, one is a string. One is something that you can do math with. And the other one, when you use the plus symbol, it's just going to combine them. So we're going to learn one last quick little thing here before we're done with the lesson for today. And that is another command called parse int. And whatever you put in there, you can even put a string in there, like the string 5. And this is specifically made for taking a string, taking a text message, and trying to learn from it, trying to decipher from it an actual number. So if you do 5 plus 5, that's not going to work. That's not going to give you the results that you want to get. But if you do parse int, and you can get a number out of that, so let's say we do parse int with a string in there plus 5, that's actually going to do the mathematical calculation. It's going to convert from just being plain text that nobody cares what's inside of it. It's not even math. It's not even a number. It's just plain text. And we convert that into a meaningful mathematical number. Then we can actually perform the math on that. So if we did our whole program from before with the alert, with the prompt, and we add this parse int part over there, we will be able to add the number 7 with the number 10 like we did before, because by using parse int, we're converting a number into text. But that's already something for a little bit later. That's not the most important. The most important now is you guys to get used to the idea of creating variables, the fact that you can put inside of variables stuff, the fact that you can read that stuff, what's inside of that variable. You can change what's inside of that variable. You can add, you can subtract. If it's a number, of course, if it's a number, you can do that stuff with it. If you have a string like this, and you try to do this times 34, you're going to get an error, NaN, which stands for not a number. Anytime you do something weird like this in JavaScript, it'll complain to you with, that's not a number. I can't actually do math with that. So your code is going to have that error in it, and your code is going to have to deal with it and figure out what to do if you have NaN, if you have a not a number error, etc., etc. Now, as for the homework right now, we touched on a few topics of programming very, very briefly. It was introductory. It was a little bit slow for some people and a little bit too fast for others. I would highly recommend two things. First of all, to complete and to finish up on the CSS stuff that we learned already before, I would highly recommend to go to the website that Label recommended, freecodecamp.org. go over there to the second, hang on, responsive web design. That's the first one over there. Scroll down, go to, there's the basic HTML section. You can go through that as well. It's a great thing to go to exercise your HTML knowledge. Also go through the second one, basic CSS. This will literally go through almost all the different options you have in CSS and give you a fun little exercise to do with it and to show you what it does. Change the font size of an element. You go inside over here, it gives you an example page, and it tells you, change this to make it this way, and change that to make it that way. For example, inside the same style tag that contains your red text class, create an entry for P elements and set the font size to 16 pixels. These are very, very good exercises for you to familiarize yourself, to get used to know how it works, and to learn a whole lot of different CSS things that you can do that you didn't know you could do. Here we have, I may have gone into the wrong one. Oh, no, I did. I wanted to, yeah, change font size. After you're done with the basic CSS, there's even further things you can do. Applied visual design. There's a bunch of different things you can do around here to space things out, to put borders around things, visual design stuff. Here you have some of those responsive things we were talking about to make your web page work on many different devices and sizes. This is very, very important for you guys to do. CSS Flexbox, CSS Grid. This is fundamental. Very important to go through this. And finally, start playing around with variables and showing things with the alert command in JavaScript by opening up your console and writing in some JavaScript code over there to mess around with variables, get a good grip on how that works, and go through some exercises in the JavaScript section of this website as well. Basic JavaScript, introduction to JavaScript, comments. You know, your practice is to try creating one of each type of comment. So what are comments? It explains to you what comments are, how to write them, etc., etc. Go to the next lesson, etc., etc. You can learn from here a lot of important things, which we're not, this is because this is kind of a crash course. We're not going to be able to cover all of it thoroughly. We're going to rely a lot on you guys going through some of these exercises and learning and reviewing a little bit more. Oh yeah, I remember we spoke about variables. That makes sense to me. And with this lesson that I'm learning over here, and this makes sense. You see right here, he's showing you guys about variables and about adding and about assigning the results of adding the variables to each other into the variable right over here. It's all happening. You guys can learn all about it here. So I'd highly recommend you guys go through some CSS in Free Code Camp, go through some JavaScript in Free Code Camp. I'm going to post links into the Slack channel, so you guys have links specifically to the parts that I'm referring to. And open up your inspect element console, mess around and play around with some things over there. Start getting used to playing around with JavaScript programming, with variables, numbers, mathematical operations, and showing things with alert and with prompt. Thanks so much, everyone, for joining us today. Hope to see you again next time. And please join us again in the Slack chat rooms. We're here to answer some questions. Not always available for all the time for everything, but trying our best. And I really appreciate everyone that also helps each other. Label, if you're there, if you wanted to add anything else, please let me know. Otherwise, thanks everyone so much for joining us, and we will see you guys next class, Imran Hashem.